Hello students, welcome to your mathematics class. Today in this video, you will learn about the chapter Understanding Quadrilaterals. So now in this video, let us know about some special types of quadrilaterals which are also known as special types of parallelograms. One of the special type of parallelogram is rhombus. Now what do you mean by rhombus? In a parallelogram, if a pair of adjacent sides are equal, then it is called a rhombus. Or in other words, we can say that a parallelogram having all sides equal is called a rhombus. So, if we consider ABCD as a quadrilateral, then a quadrilateral ABCD is a rhombus if AB is parallel to CD and AD is parallel to BC and AB is equal to BC equal to CD is equal to DA. So in this way also we can define a rhombus. Now let us verify that all sides of a rhombus are equal. In order to prove that all sides of a rhombus are equal, let us consider ABCD be a rhombus. The figure is already shown here, ABCD, which is a rhombus. Now here we have to prove AB equal to BC, BC is equal to CD and CD is equal to DA. We know that a rhombus is a parallelogram which has a pair of equal adjacent sides. So from this definitions we can write from figure that AB and AD are the adjacent sides. So this adjacent sides are equal. So therefore AB equal to AD. Also in a parallelogram, opposite sides are equal. So from this we can write from figure AB is equal to CD. These two are opposite sides. So these two opposite sides are equal. Also AD is equal to BC. Now if we combine all these three equalities, then we can write that AB is equal to CD, also AB is equal to AD and AD is equal to BC. So if we arrange them according to the figure, then we can write AB is equal to BC is equal to CD is equal to DA or AD. So which shows that all sides of a rhombus are equal, which is the required proof. Now let us verify one of the important property of a rhombus, that diagonals of a rhombus are perpendicular to each other. So in order to prove that the diagonals of a rhombus are perpendicular to each other, let us consider that ABCD be a rhombus in which diagonals AC and BD are intersect at point O. So the figure is already shown here. ABCD is a rhombus. Here AC and BD are the two diagonals which are intersecting at point O. So here in this case we have to prove that AC is perpendicular to BD, or in other words we can say that angle BOC is equal to angle COD is equal to angle DOA is equal to angle AOB is equal to 90 degree. Since every rhombus is a parallelogram, so it has all the properties of a parallelogram. Also we know that in a parallelogram diagonals bisect each other. So from figure we can say that AO is equal to OC and OB is equal to OD. Now if we consider the two triangles, that is triangle BOC and triangle DOC. In this two triangle we can see that OB is equal to OD, because we know that in a parallelogram diagonals bisect each other. So by using that property we can write this equality that OB is equal to OD, which is already written the statement here by 1. We can say that by 1. Also OC is equal to OC. In this two triangle OC is a common side. So these two common sides are always equal. And BC is equal to CD. So BC is equal to CD. As it is a rhombus, so we know that all sides of a rhombus are equal. So BC is equal to CD. We can write So in these two triangles we can see that the three sides of triangle BOC are respectively equal to the corresponding three sides of the triangle DOC. So these two triangles are congruent. That is, triangle BOC is congruent to triangle DOC by side congruence rule, or in short we can say SSS congruence rule. So if two triangles are congruent, then we know that their corresponding parts are equal. So from that we can say that angle BOC is equal to angle DOC, which is already written here. Angle BOC is equal to angle COD, that is in short by CPCT. So now these two angles are forming linear pair of angles, as these two angles are adjacent angles and they are on a straight line. So these two angles are forming linear pair of angles. So their sum will be always 180 degree. So this is by linear pair. Now, since these two angles are equal, so we can write 2 into angle BOC is equal to 180 degree. So this implies angle BOC is equal to 90 degree. So which also implies angle COD is also equal to 90 degree. So according to this we got here 90 degree. This is also 90 degree. So now if two angles are also, these two angles are forming linear pair of angles because these two are adjacent and they are forming angles on a straight line. So if two angles are forming a linear pair of angles, and if one of the angle is 90 degree, then another angle will be also 90 degree. So similarly we can also show that this angle is also 90 degree, and by same reason we can also show that angle DOA or angle AOD is also 90 degree. So in this way we can say that angle BOC is equal to COD is equal to DOA is equal to AOB. Each angle is equal to 90 degree or right angle. Now that means, which shows that AC line is perpendicular to BD. So we can say that diagonals of a rhombus are perpendicular to each other. So let us know about the properties of a rhombus. Since every rhombus is a parallelogram, so it has all the properties of a parallelogram. That is, opposite sides are equal, opposite angles are equal, the adjacent angles are supplementary, and diagonals bisect each other. And also it has some other special properties. That is, all sides of a rhombus are equal and the diagonals are perpendicular to each other. So we can say that in a rhombus all sides are equal and the diagonals bisect each other at right angles. So from these properties we can say that every rhombus is a parallelogram, but every parallelogram is not a rhombus. Now let us know about another special type of a parallelogram, that is rectangle. So a parallelogram whose each angle is a right angle is called a rectangle. Look at this figure. Here a parallelogram ABCD is a rectangle if angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. So in a parallelogram, if each angle is 90 degree, then it is called a rectangle. And in short, we can write the symbol of a parallelogram as this. This is the short symbol of a parallelogram. Now, let us verify that if one angle of a parallelogram is a right angle, then it is a rectangle. So let us consider that ABCD be a parallelogram in which one of the angle is 90 degree. That is, angle A is equal to right angle. Since we know that adjacent angles of a parallelogram are supplementary, so we can write angle A plus angle D is equal to 180 degree, but angle A is here 90 degree. So we can write this implies angle B is equal to 180 degree. minus 90 degree, that will give 90 degree. So angle B is equal to also 90 degree. Also we know that opposite angles of a parallelogram are equal. So from this we can write angle A is equal to angle C, that is equal to 90 degree, because angle A is already we considered as 90 degree, and angle B is equal to angle D is equal to also 90 degree. So from figure, in a parallelogram ABCD, we have angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. So we can say that ABCD is a rectangle. Now let us see one of the important property of a rectangle, that the diagonals of a rectangle are equal. So let us consider that ABCD be a rectangle, which is already shown here, that ABCD is a rectangle in which AC and BD are the two diagonals. So now we have to show here that the two diagonals are equal, that is AC equal to BD. So now if we consider the two triangles, that is DAB and CBA, in these two triangles we have AD is equal to BC, because these two are opposite sides. We know that in a rectangle opposite sides are equal, and also DAB is equal to CBA, each of the angle is 90 degree. We know in a rectangle all angles are 90 degree. So also AB is equal to BA is a common side. So these two sides are equal. So from these three conditions we can say that by side angle side congruence rule, these two triangles are congruent. That is, triangle DAB is congruent to triangle CBA. So by side angle side congruence rule, or by, in short we can say by SAS congruence rule, these two triangles are congruent. Also we know that if two triangles are congruent, then their corresponding parts are equal. So from this figure we can say that in triangle DAB we can write DB is equal to, in triangle CBA we can write CA or AC. So from this two triangles we can write by CPCT, that is corresponding parts of congruent triangles are equal. So by CPCT we can write that DB is equal to CA, that is AC is equal to BD. So which shows that the diagonals of a rectangle are equal. Now let us see the properties of a rectangle. Since every rectangle is a parallelogram, so it has all the properties of a parallelogram. That is, opposite sides are equal, opposite angles are equal, adjacent angles are supplementary, and diagonals bisect each other. Also, it has some other special properties. That is, all angles of a rectangle are right angles. That means all angles of a rectangle are equal and is equal to 90 degree. The diagonals of a rectangle are equal. So these are the two special properties of a rectangle. So we can say that the diagonals of a rectangle are equal and bisect each other. So from these properties we can conclude that every rectangle is a parallelogram, but every parallelogram is not a rectangle. Now let us do one example, that the diagonals of a rectangle ABCD intersect at O. If angle BOC is equal to 44 degree, find angle OAD. Look at this figure. Here ABCD is a rectangle in which the diagonals AC and BD are intersecting at point O, and one of the angle is given, that is angle BOC is given here 44 degree. So we have to find out here the measure of angle OAD. Let us consider that the measure of angle OAD be x degree. Now from figure we have angle BOC is equal to 44 degree. So that we can also write angle BOC is equal to angle AOD, because these two angles are vertically opposite angles. So we know that vertically opposite angles are equal. So we can write angle AOD is equal to also 44 degree. Also we know that in a rectangle diagonals are equal. So here AC equal to BD. So if we multiply both sides by half, or if we divide both sides by 2, then AC by 2 is equal to BD by 2. So half of AC. Also in a rectangle diagonals bisect each other. So half of AC will be AO and half of BD will be OB or OD. So from this we can write OA is equal to OD. So OA is equal to OD. So now if we consider triangle AOD, and if in a triangle we know if opposite sides are equal, if two sides are equal in a triangle, then that triangle is called an isosceles triangle. So here triangle AOD is an isosceles triangle, and the angles opposite to equal sides of an isosceles triangle is equal. So here the opposite sides are equal, so their opposite angles are also equal. So from this figure we can write angle ODA is equal to angle OAD. Both are same measure, that is x degree, because the angles opposite to equal sides of a triangle are equal. So now if we consider triangle OAD, in this triangle one of the measure already we got, that is 44 degree, and other two measures are x degree, and this is also x degree because these two angles are equal, and we know the sum of three angles of a triangle is 180 degree. So from this we can write x degree plus 44 degree is equal to 180 degree by angle sum property of a triangle. So now if we calculate this, we will get here 2x degree is equal to 136 degree. This implies x degree equal to 68 degree, which means that the measure of angle OAD is equal to 68 degree. Now let us know another special type of a parallelogram, that is a square. A parallelogram having all sides equal and each angle equal to a right angle is called a square. Also, in other words, we can say that a square is a rectangle whose adjacent sides are equal. So, in a rectangle ABCD, if a pair of adjacent sides are equal, then it is a square. So, in this figure, if we consider the adjacent sides, suppose AB is equal to AD. Also, we know that in a rectangle opposite sides are equal, that is AB is equal to CD and AD is equal to BC. So from these three equalities we can write AB is equal to CD is equal to AD is equal to BC. That means AB is equal to BC is equal to CD is equal to DA. That means in a square all sides are equal. Since we know that every square is a parallelogram, so it has all the properties of a parallelogram. Also in a square, all sides are equal and opposite sides are parallel. So we can say that every square is a rhombus. So it has all the properties of a rhombus. Also in a square, all angles are equal and measure of each angle is right angle. So from this we can say that every square is a rectangle. So it has all the properties of a rectangle. So from this we can conclude that a square has all the properties of a parallelogram, rhombus and a rectangle. So in a square all sides are equal, all angles of a square are equal and each angle is a right angle. Also, the diagonals of a square are equal and bisect each other at right angles. So, these are the important properties of a square. Now, let us do another example. PQRS is a square if PQ is equal to under bracket 8x minus 12 units and QR is equal to under bracket 5x plus 18 units. Then find the length of each side of the square. We know that in a square all sides are equal. So from figure we can say PQ is equal to QR is equal to RS is equal to SP. So from this relation we can only take PQ is equal to QR. We put the values whatever given in place of PQ, that is 8x minus 12 is equal to 5x plus 18. If we solve this equation, we get the value of x is equal to 10. So we put the value of x equal to 10 in PQ. So we get 8 multiplied by 10 minus 12 under bracket units. So that means we get PQ is equal to 68 units. So here in this question it is asked that find the length of each side of the square. So the length of each side of the square in this question is 68 units. In this way you try some questions which is given in your book. I hope all of you understood whatever discussed today in this video. So thank you all of you and have a nice day.